Guys, here are the answers to homework number 6. Pay close attention on the graphs to do you have the lines graphed in the correct spots? Are they correctly solid or dashed? And did you shade the correct side? Here's the answers. All right, let's go through the problems. I will do these color-coded. In this first one, the y-intercept is -2. It's got a slope of up 3, right 1. So I can graph it fairly quickly. It's a dashed line because it's not or equal to. And since y is greater than, it is on the above the line side. The second line, if I put it in slope-intercept form, it would be y is less than or equal to 1/2 x plus 3. So it has a y-intercept of 3. It has a slope of up 1, right 2, or down and to the left. It is a solid line. And it is less than, y is less than, so I'm going to shade underneath the line. And so my region of my graph that is shaded by both lines is this wedge right in here. And so my graph would look something like that. Number 2. The first equation is already in slope-intercept form, so I'm going to go ahead and put a dot at the y-intercept, -2. It's got a slope of down 1, right 1. Hello. Let's see if this will keep going. Down 1, right 1, or up and to the left. This one is a dashed line because it does not have an or equal to. And of course I made it a solid line. Let's try it again. And it is less than, so it's going to be shaded below the line. The other line is also in slope-intercept form. It's got a y-intercept of 3. It's also got a slope of up 3, right 1, or down 3, left 1. It's going to be a solid line because it's got an or equal to. And it is greater than, so it's going to be above the line. And so my region where my solutions are, the double shaded region, would be that region in there. There's your solutions. Problem number 3, it's already in slope-intercept form. It's got a y-intercept of 4. It's got a slope of up 2, right 1, or down 2, left 1. It is a dashed line because it does not have or equal to. And it's greater than, so it's going to be above the line. The second equation is not in slope-intercept form, but if I added 2x to both sides, it would be. It has a y-intercept of -5. It's got a slope of up 2, right 1. It is shaded, let's see, it's a solid line because it's got or equal to. Oops. And it is shaded, since it's less than, it's shaded below the line. So this graph has no double shaded area. And because it has no double shaded area, there are no solutions to that system. All right, last up, we got x is greater than 2. So that would be a a vertical line at 2, and it would be dashed. And greater than 2 would be numbers to the right of that line. Then we've got a horizontal line at y equals 1. That's going to be a dashed line also. And the y values are greater than 1 above that line. And last up, we've got this line. If I subtracted 2x from both sides, and I divided by 3, I would have a y-intercept of positive 4. I would have a slope of down 2, right 3. This would be a dashed line because it doesn't have or equal to. And since it's less than, I would be shading below the line. So what you kind of got to keep track of there is which side of each line you're on. I am below the green, I am to the right of the red and above the blue, and that puts me in this little triangle. Right here are my solutions. All right, now we have a big graph. These story problems. It says cherries cost $4 per pound, and grapes cost $2.50 per pound, and I can spend no more than $15. It also says I need at least 4 pounds in all. All right, so I'm graphing here is how many pounds of grapes can I buy and how many pounds of cherries can I buy. So I'm going to set up two variables. X is going to be pounds of cherries that I can buy, and the Y will be pounds of grapes that I can buy. So over here on the x-axis, I'm going to put pounds of cherries. And on the y-axis, I'm going to put pounds of grapes. And I'll number it after I write a couple equations. So the red lines give me one equation. They give me the price, right? There's two restrictions. The first restriction is I can't spend more than $15. So the cherries would be $4 per pound, so 4 times X would be the cost of the cherries. And the grapes cost $2.50 per pound, so it'd be $2.50 times Y. And when I add those together, I get the total cost of all the fruit, and that's got to be less than or equal to 15. The blue part that I underlined is the other restriction. The restriction is I have to buy at least 4 pounds worth of fruit. So the pounds of cherries I buy plus the pounds of grapes that I buy have to be greater than or equal to 4. All right, so let's see. I think the best way to number this is going to be to spread out my numbers. I'm going to go by halves. So every other line will be 1. And I can do that on both axes, I think. There we go. All right, so let's do the x first. It looks easier. The x-intercept would be 4, and the y-intercept would be 4. So let's go ahead and put a dot at 4 on the x-axis and 4 on the y-axis. And this would be a solid line I get connecting those 2 points. And let's put in 0. 0 is great, that's false. This is going to be above the line. When I put 0 into the equation, it was not true, so the answers are on the other side of the line. The red equation, the x-intercept is going to be at 3.75, and the y-intercept is going to be at 6. So let's put a dot at 6, and at 3.75, that's not very good. That's terrible. The board is hard to do with this. My line would look something like this. And the red line would be shaded. Let's see, 0. If I put 0 in, I get 0 plus 0 is less than 15. That's true. It would be shaded below. So my double shaded area would be the area in this little wedge right here. And it looks like it would stop right where these lines kind of cross. So it'd be that little triangle right there. All right? That's just practice. Here comes the big one. Number 6. All right, tough question, right? It is. I'm buying dress shirts and I'm buying t-shirts. And the question is, how many of each shirt can I buy? So first I'm going to set up two variables. I'm going to have x be the number of t-shirts I can buy. And I'm going to have y equal the number of dress shirts that I can buy. Now, there are several restrictions here. The first restriction is I can spend no more than the amount of the gift certificate, which was $100. Okay, so that gives me an inequality. It says the cost of all these have to be less than or equal to $100. Well, the t-shirts cost 15 bucks, so 15x would be the cost of X number of t-shirts. And the dress shirts cost $22, so 22y. That would be the cost of all my shirts, and that has to be less than or equal to $100. That's the first restriction. The second restriction is I want to leave at most $10 on the gift certificate unspent. That is a weird way of saying I want to spend at least $90. So the $100 gift certificate only has $10 left unspent. So that means that when I buy these t-shirts at $15 each and these dress shirts at $22 each, I have to spend greater than or equal to $90. And there's one more restriction, and the last restriction is I need at least one dress shirt. So the number of dress shirts has to be greater than or equal to 1. Those are my 3 restrictions. Let's go ahead and graph these. I'm going to try to do this accurately. I spent more time doing it accurately on the answer key, but I'll try to go here. Not easy on this board. So this one looks the easiest. Let's do the green one first. That would be a horizontal line at 1. And that would be shaded above the line. So I'm just going to kind of keep track. The shading so far is above the green line. The graph will not be quite so messy. If I had paper and pencil, I could do it better, but on the smartboard, the graph will not be quite so messy if I don't put all the shading in quite yet. All right, the red line. So for the red line, the x-intercept would be 100 divided by 15, which is 6 2/3. And the y-intercept would be 100 divided by 22, which is a little bit more than 4.5. It's barely more, it's 4.5, 4.6. So let's kind of estimate those. The y-intercept is going to be about right here at 4, a tiny bit above 4.5. 4 12/22, or 6/11. And the x-intercept is at 6 2/3, which is about right there. So when I connect those, I'm going to do the best I can here. I used a ruler when I did my on paper, it would be about like that. Okay. Oh. And the red line would be shaded below, because 0 plus 0 is less than 100. So I'd shade on the side 0 is on. The blue line has an x-intercept exactly at 6 and a y-intercept at barely above 4. Be 4 and 1/11. It'd be about 4.1. So let's go ahead and put a dot on the y-axis at about 4.1. And on the x-axis, exactly at 6. And let's connect those. And the blue line, when I shade it, let's see, 0 plus 0 is greater than 90, that's false. The blue line would be shaded above. So if you've kept track of the shading, the area that is shaded by all three lines is above the blue, below the red, and above the green. It's this area in here. Okay, that's pretty good. So now, the last part of this question is, name all the possible combinations of shirts that I could buy. All right, so one thing is, this is a discrete graph, right? It's discrete because you cannot buy a fraction of a shirt. Only whole numbers make sense. So I want all the possible combinations of shirts, but only whole number combinations. So let's start looking for whole numbers that are in our black area. When x equals 1, 1, 3 is not in our black area. 1, 4 looks close. And let's see, I think that 1, 4 is actually just outside the area. If you did this neatly, you'd see that. So 1, 4 is not a good point. Let's go over to 2. 2, 1 does not work. 2, 2 does not work. But 2, 3 is right in our area. So that's a good point. Let's go to 3. 3, 1 does not work, but 3, 2 is right in our area. So that's a good point. Let's go to 4. 4, 1 does not work. 4, 2 is too high. The 4 is out. And last we go to 5. 5, 1 is actually right in our area at the corner. So I actually end up with 3 ordered pairs that are in the black area if you did this really neatly. And those points are 2, 3, 3, 2, and 5, 1. So there are 3 possible combinations, right? 3 combinations of shirts that I could buy. The X is the t-shirt, so I could buy 2 t-shirts and 3 dress shirts. Or I could buy 3 t-shirts and 2 dress shirts. Or I could buy 5 t-shirts and 1 dress shirt. Those are the 3 points that lie in the solution area. All right, that takes us to the last set. This was just practice writing equations. In this first equation, it's a mixture problem. And I want to make 10 liters. So that means the first amount plus the second amount needs to add up to 10. And I am mixing, let's see, 28% is the first amount. So 28% of X and 42% of Y needs to equal 33% of the mixture. So that would be 33% of 10. Or maybe you multiplied that and got 3.3. That would be your two equations. Number 8, it's an investment problem. X would be the amount invested at 9%, and Y would be the amount invested at 5%. And so my equations would be X plus Y needs to equal 3,200. That's the total amount invested. And the amount invested at 9% times 0.09 would be the amount of interest I got off that investment. The amount of interest on the second investment would be 5% times the amount invested. And when I add those together, I get the total amount of interest, which is $480. Number 9. All right, so number 9 is one of these break-even problems. That means I need a cost equation and I need an income equation. My cost equation would be $1,400 and $21 for each wig. So Y would equal 1,400 plus 21x. The income equation would be that I sell the wigs for $49 each, so the amount of money Y, remember Y equals dollars, and X equals the number of wigs. So the amount of money I'm making would be $49 times how many wigs I sell. And last up, we got the class trip to Washington, D.C. I'm going to use X for the number of students, and I'm going to use Y for the number of adults. And I know that 56 people went, so that would be the number of students plus the number of adults adds up to 56. I also know that each student brought 2 bags, so 2 times X would be all the bags that the students brought. And 3 times Y would be all the bags that the adults brought. And in all, there was a total of 124 bags, so that adds up to 124. That takes care of it.